Okay, let us start with earth ground. Earth ground means sending current directly into the ground. Ground or earth is considered as a huge neutral sink, which is very close to 0 volt of potential, or it is also called as ground potential or just the ground. It provides a low potential path for the current to flow, and the current will follow that low potential path and go into the ground and diffuse there without causing any damage which it would have otherwise caused. So according to National Electrical Code, that by definition, earth ground is the one in which this type of conducting rod or conducting wire is driven deep into the earth, and this depth should be at least 8 feet into the ground. Then according to the standard definition, it should be considered as earth ground. Okay, so there are different sources which can cause such type of currents, which can cause damage to the structures and to human lives as well. One of them, the natural biggest reason, is the lightning during thunderstorms. If it strikes a building, it can cause immense uh, destruction and damages in there, not only to the structures but also to the human lives and other valuable items in there. So that, and the building is also grounded. The building is grounded using an lightning rod on the top of the building, which collects all the current from the lightning strike, and through the conductor it dumps that huge amount of current into the ground, which there safely goes and diffuses into it without causing any damage. So the other source of unwanted currents which may occur because of anything due to malfunction of devices, short circuiting, or anything. So for safety reasons, all those electrical appliances in a building are connected to a ground plate. Like in this oscilloscope, the grounding circuits are the BNC, the outer shell of the BNC connectors are grounds, are considered as ground lead terminals, or the ground lead terminals, and this one is also for the probe. This is also ground. So these grounds from various uh, electrical appliances or wherever is necessary, those are connected to uh, copper plate or this copper strip, which is provided in the building at several locations wherever conveniently necessary. So those are it provides electrical connections and we can connect all the electrical appliances directly on this copper strip, and with this copper strip is then connected with this rod or this type of wire, which eventually grounds the current, and this is how grounding of appliances is performed. Okay, this was oscilloscope is just an example. If you look at the three pronged plug, the top prong means one of the three, the biggest one is also earth or the ground connection with that prong, so that is also considered as a grounding connection. So like this one, you can see in the labs or in the buildings, certain means in the portions wherever they have designed it to be. So this is for the safety purposes, but it does not always mean the same. So we should when electronics is concerned, it's not always sending current to the ground, but it may mean different things. Also it depends on the context we are talking about and the type of circuit we are dealing with. Okay, there are different types of grounding symbols that we can see. So in these are the main ones: chassis ground, earth ground, and signal ground. The chassis ground symbol looks like a leaf sweeper, and this is the earth ground symbol in which three lines are stacked with a vertical line on the top, and then there's a signal ground. This is different from the other two. So the earth ground symbol has two uh, sub symbols, you can say. This is the general one, and then this one with the semicircle on the top, inverted semicircle, it is noiseless earth. And the one with a full circle enclosing the earth symbol is called as protective earth. And the one that with one vertical line and a downward pointing triangle is the signal ground.